All right, in today's notes, what we're trying to do is what happens if I have an equation that's not in a standard form for conics and I need to graph it. So the first thing you need to do is analyze the equation that you have and determine what type of equation it is. And you're going to go back to our flowchart notes. Remember, there's a series of questions that we ask. And the first question we ask ourselves is there an x squared and a y squared term? The answer is no, so that means it's definitely going to be a parabola. And we notice that the y is the squared term, so that means this is going to be a parabola that is a horizontal parabola because x is not a squared term. All right, so next what we're going to do is try to factor this into a perfect square trinomial, so that way it'll look more like the standard form for parabola so we can graph it easier. All right, so to do that, we need to kind of isolate the part that we need to factor in a perfect square trinomial, which is this part. So negative 13 has to move to the other side temporarily for us. We're going to do a plus 13 on both sides. All right, and now what I'm going to do is factor out negative 3 because when we factor, remember the first step is always to GCF. So I take out the negative 3 factor. All right, now what I'm going to do is leave space because this is the part that I need to turn into a perfect square trinomial, which means what we're ultimately going to be doing is completing the square. So I'm adding this blank here. This blank is in parentheses, and negative 3 is in front of the parentheses group. That means when I'm adding to both sides of my equation to complete the square, I'm not adding just whatever this blank is. I'm going to have to be adding 3 times the blank, whatever we need to complete the square. All right, so completing the square, remember we kind of follow this template. What we're going to do is take half, and then to get this number, we take that number, now square it. So what I have to do is add 4 here, which means on the other side of the equation to balance it, I have negative 3 times 4 that I'm adding to the other side of the equation. All right, so x plus 13 minus 12 reduces to x plus 1 equals, and then I have negative 3 times y plus 2 quantities squared. We're almost there for it to look like the standard conic for a parabola, and we just have to subtract 1 now. And so the form now looks like x equals negative 3 y plus 2 quantities squared minus 1. All right, now we're ready to graph this. Okay, so this is where you guys are going to hit pause and graph this on your own and then check your work. All right, so since the scale factor was negative, that means we're going to be opening to the left. Remember to watch out for that vertex, that this value of 2 really belongs with the y position, and it's going to be negative because it's inside parentheses. And then you're going to do your scale factor of 3. So really we only have room on the graph for the vertex and a pair of points. All right, on our next example, we're going to ask ourselves the flowchart questions to try to figure out what type of equation we're supposed to have here. Your first question on the flowchart is there both an x and y squared term? And the answer is no, so this is definitely a parabola. This one has an x squared term, so this parabola is going to be a vertical one, opening either up or down. All right, so now what we're going to do is kind of the similar method as before. We're trying to isolate the part that needs to turn into a perfect square trinomial. So that means I have to move the negative 8. So we're going to add 8. So y plus 8 equals 1/2 x squared plus 2x. Then we're going to take out the greatest common factor, which is half. So 1/2 is going to be factored out, and there are 4 halves and 2. And then I'm going to leave a blank so that I can complete the square on this side. So on the other side of here, I still have my y plus 8, and I'm going to have to leave a plus 1/2 blank. Because remember, again, we took out a half over here, so we're not just adding a blank, we're adding half the blank to make it equal to the other side and keep everything nice and balanced. All right, so completing the square method means that I start my template. To get the number that goes here, we're going to look at our b term, divide by 2. Then to get this blank, we're going to take that number and square it. And then I put it over here. Now for cleaning things up, right? This still has a 1/2 in front. Half of 4 is 2, so y plus 10 equals 1/2 of x plus 2 quantity squared. Almost looks right for our conic standard function, so we just need to subtract 10 on both sides. So y equals 1/2 x plus 2 quantity squared minus 10. And now it's ready to graph. So again, hit pause and then check your graph with mine. Okay, so check your work. We grabbed our vertex from the HK values. Our scale factor was positive 1/2, so that meant my parabola was facing upward.